Hello everyone, welcome to another video. In this video what we are going to look on is complex number are imaginary numbers, right? But before I get into what are complex numbers, let's say that we have this quadratic equation which is x squared minus 4x plus 5 equals 0, and you are asked to solve this quadratic equation using the quadratic formula which is written here. So the formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Now a here is going to be the coefficient of the x squared term, so a is going to equal to 1. B is going to be the coefficient of the b term, which is going to equal to minus 4. And c is going to be the constant, which is positive 5. Now we can plug these values into this formula, right? So x is going to equal to minus negative 4, right? Plus or minus the square root of minus 4 all squared minus 4 times a is 1 in this case, times c is 5 in this case, all of that divided by 2 times a, which is 1, right? So x is going to equal to negative times negative 4, that's going to be positive 4, plus or minus the square root minus 4 all squared, that's going to be 16, minus 4 times 1, that's 4, 4 times 5, that's 20, so that's going to be minus 20, all over 2, because 2 times 1, that's just 2, right? So x is going to equal to 4 plus or minus the square root of 16 minus 20, that's going to be negative 4, right? All over 2. Right? So x is going to equal to here, it's going to equal to positive 4 plus or minus. I'm going to rewrite minus 4 as a product of two numbers, so this is the same thing as the square root of negative 1 times the square root of 4, right? All of that divided by 2. So this will give me x equal to 4 plus or minus, what's the square root of 4? That's going to be 2, right? So this is going to be 2 root of negative 1 all over 2, right? Each of these numbers can be divided by 2, so x is going to equal to 2 plus or minus root of negative 1, right? So that's going to be the root of this quadratic. Now this answer here that we got, which is 2 plus or minus root of negative 1, is what we call an imaginary number, right? So this is what we call an imaginary number. What we can note from this imaginary number, it is made up of two parts. This part where 2 is what we call the real part. So this part where root of negative 1 is what we call the imaginary part. Now, root of negative 1 is defined as I. So we say that I is equal to the root of negative 1. That's how we define the root of negative 1. So because it's imaginary, we get a I. So I is equal to the root of negative 1. Now, if we square both sides of this equation, we can see that I squared is going to equal to negative 1, right? So I squared is equal to negative 1, right? So what is I raised to the 0 power? If we raise I to the 0 power, then anything raised to the 0 power gives us 1. So this is just going to equal to 1, right? So I to the 0 power is equal to 1, right? So what is I raised to the first power? So I raised to the first power, anything raised to the first power gives you back itself. So I raised to the first power is just going to be I. Clear there? And when we're talking about imaginary numbers, these are just some of the facts that you need to remember. So you need to remember that I is equal to the root of negative 1. You need to remember that I squared is equal to negative 1. You need to remember that I to the 0 power is equal to 1. And you need to remember that I to the first power is just going to equal to I. Right? Now, could you guess and tell me what do you think I to the third power would be? If we have I to the third power, then we can rewrite this as being I squared multiplied by I to the first power. Right? So here we know that I squared is just negative 1, so this would be negative 1 times I to the first power, which is just I. So I to the third power is going to equal to negative I. Alright? And you can ask to find I to any amount of power, I to the 10 power or so forth. Alright? So, in other words, what is a complex number? A complex number is a number that is made up of a real part and an imaginary part, right? So the real part are like real numbers, right? And the imaginary part has to do with I. So there's a general form that we use to represent complex numbers, and I'm going to show you that form right now. So we write complex numbers in the form, let's say we have the complex number z. Z is equal to a plus bi. Right? So that's one form where a is the real part and bi is the imaginary part. Right? Or we can say that z is equal to x plus iy. Or yi, doesn't matter if you put the I first. Alright? So this is basically a number of this form is what we call an imaginary numbers, right? So we can use either a plus iy, and plus and minus doesn't matter, right? So it's either a plus or minus bi or x plus or minus yi, right? Where a in this case is the real part and bi is the imaginary part. In this case, x is the real part and yi is the imaginary part, right? So now that you have a good understanding of what complex numbers are, what we are going to do, we are going to look at how we add and subtract complex numbers. So what we are going to focus on is addition and subtraction of complex numbers. So here we have an example. Given that z is equal to 4 plus 3i and w is equal to 7 minus 8i, find part I, z plus w, right? So z plus w is going to equal to, z is defined as 4 plus 3i and w is defined as 7 minus 8i. So what we're going to do, we're going to add the real parts together and add the imaginary parts together. Alright? So we have 3i. So we have, you can put this in a bracket. So we have 3i plus negative 8i. Negative is going to overrule. So in other words, we just have 3i minus 8i, and that's going to give us minus 5i. Here we have 4 plus 7, and that's going to give us 10. Right? So our final answer is going to be 10 minus 5i, right? Straightforward, right? For the second one, we have z minus w. That is going to equal to 4 plus 3i, right? Minus w, and w is defined as 7 minus 8i. And again, you're just going to subtract the imaginary part from the imaginary part and the real part from the real part. So we have positive 3i minus 8i. These two minus are multiplying, so it's going to become plus. So this is just going to be plus 11i. Here we have 4 minus 7i. Sorry, here we have 4 minus 7. That's going to leave us with negative 3. So our final answer is negative 3 plus 11i. Now to the final question, which is w minus z. W is defined as 7 minus 8i. All of that subtract z, which is 4 plus 3i. Now this is minus 8 minus 3i. That's going to give us minus 11i. And this is going to be 7 minus 4. This is going to be positive 3. So our answer here is going to be 3 minus 11i. Alright? And that's it. So that's how you add and subtract complex numbers. All you're doing, you're adding the real part to the real part and adding the imaginary part to the imaginary part. Or if you're asked to subtract, you're subtracting the real part from the real part and the imaginary part from the imaginary part. Okay?
Are you studying mathematics at the tertiary level? Then, if so, Timori White's YouTube channel is definitely for you.
So now we're going to focus on how we multiply complex number, right? So we are given the complex number w is equal to 3 plus 4i and z is equal to 2 minus 2i. And we are asked to find wz, right? So wz means w times z. So that's going to be w, which is 3 plus 4i, that's in a bracket, times z, which is defined as 2 minus 2i. Right? Now, how are we going to multiply this? We are going to use distributive law, right? So we are going to take the first term in the first bracket to multiply the first term in the second bracket. So 3 times 2, that gives us 6, right? We're going to take the first term in the first bracket to multiply the second term. So 3 times negative 2i, that's going to give us negative 6i. We're going to take the second term to multiply the first term. So positive 4i times 2, that's going to give us positive 8i. Then we are going to take the second term to multiply the last term here. So 4i times minus 2i, that's going to give us a minus 8i squared. Note that we have two imaginary parts here in the middle. So that means we can combine these together. So this is going to be 6 minus 6i plus 8i, that's going to be plus 2i, alright, minus 8i squared. Recall that I squared is equal to negative 1. Right? So we can sub negative 1 here for I squared. So this is going to equal to 6 plus 2I minus 8 times negative 1. So this is going to equal to 6 plus 2I minus 8 times 1, that's going to be plus 8. Here we have a real number which is plus 8 plus another real number which is 6. So 8 plus 6, that's going to be 14. So our final answer is going to be 14 plus 2I. Right? And that's how you would multiply two complex numbers. And most times you're asked to write it in the form A plus or minus BI. So it is already in that form, right? Because the 14 is a real part and the 2I is an imaginary part. Alright? Now, we're also asked to find W squared. Right? So W squared means W times W, right? So this means W multiplied by W. So what is W? W is defined as 3 plus 4i. So this is going to equal to 3 plus 4i times 3 plus 4i. And it's just the same idea. Use the first term to multiply the first term. So it's going to be 3 times 3, that's going to give us 9. Then we use the 3 to multiply the second term. So it's going to be 3 times plus 4i, that's going to be plus 12i. Then it's going to be 4i times 3, that's going to give us plus 12i. And then it's going to be 4i times 4i, which gives us plus 16i squared. Alright? Now, this can be simplified to be 9 plus 12i plus 12i, that's going to give us 24i. Remember that I squared is not negative 1, so this is going to be plus 16 times negative 1. Alright? So 16 times negative 1, that's just minus 16. Minus 16 plus 9, that's just going to give us minus 7 plus 24i. And that's it. Alright? Let's look at our final problem. We are asked to find z squared, and we know that z squared is the same thing as z times z, and z is defined by 2 minus 2i times 2 minus 2i. So take the first term to multiply the first term. 2 times 2, that's going to give us 4. Then the first term to multiply the second term. So 2 times negative 2i, that's going to give us minus 4i. Take the second term to multiply the first term. Minus 2i times 2, that's going to give us minus 4i. Take the second term to multiply the last term. Minus 2i times minus 2i, that's going to give us positive 4i squared. So this is equal to 4, give us minus 8i. Right? Note that plus 4i squared is the same thing as plus 4 times negative 1, because I squared is the same thing as negative 1. So here, 4 times negative 1, that's just going to be minus 4. So we're going to have 4 minus 4 minus 8i, right? 4 minus 4, that's just give us 0 plus negative 8i, which just gives us a final answer of just minus 8i. Alright? So that's it, and that's how you multiply two complex numbers. Alright? So what we're going to look at next is how we divide two complex numbers. We're going to look at how we divide complex numbers. Right? Now there's just a few things that you need to remember. General form of a complex number is a plus or minus bi, where a is the real number and bi is an imaginary number. You need to remember that I raised to the 0 power is equal to 1, I raised to the first power is just equal to I squared is equal to negative 1, and I cubed is equal to negative I. Alright? Now, let's say that you're given the complex number v, and v is equal to 4 minus 6i, right? And you're asked to find the conjugate of v, then we use a little asterisk to represent the conjugate. So that means v conjugate is going to equal to 4 plus 6i. All you need to do is to just switch the sign in the middle to be plus. So let's say that you have a complex number y, and y is equal to 3 minus 4i. And you're asked to find the conjugate of y, then the conjugate of y is going to equal to 3 plus 4i. And that's it. So that's how you find the conjugate of a complex number. Now, we need this skill to divide complex numbers, alright? So now we have z is equal to 3 plus 2i, and w is equal to 5 minus I. And we're asked to find z divided by w. So this is going to equal to z, which is 3 plus 2i, all divided by 5 minus I. Right? Now, to divide two complex numbers, what we need to do is to multiply both top and bottom, or both numerator and denominator, by the conjugate of the denominator. So the conjugate of the denominator here is going to be 5 plus I. And we need to multiply the numerator by 5 plus I, which is the conjugate of the denominator. Right? Now, I put a bracket here as well. Now what you note here, the denominator is now a difference of 2 squared. Right? So how do you multiply difference of 2 squared? You just square the first term and subtract the square of the second term. So 5 times 5, that's going to be 25, minus I times I, that's going to be I squared. Right? Now, you just learn how to multiply two complex numbers. So it's the same idea. We're going to use the first term to multiply the first term here. So 3 times 5, that's going to be 15. Use the first term to multiply the second term here. So 3 times I, that's going to be plus 3i. Use the second term to multiply the first term. So 2i times 5, that's going to be plus 10i. And use the second term to multiply the last term here. So 2i times I, that's just going to be plus 2i squared. Alright, clear there? Now, we can group the like terms, right? So we know that here we're going to have 15. We can group 3i plus 10i, and that's going to be plus 13i. We know that I squared is the same thing as negative 1. So this is just plus 2 times negative 1 all over 25 subtract I squared, and I squared is just negative 1. So this is just minus negative 1. Alright? So this is going to give us a final answer of 2 times negative 2, that's just going, 2 times negative 1, that's going to be negative 2. Negative 2 plus 15, that's going to be plus 13. So this is going to be 13 plus 13i all over Negative times negative, that's just positive, so this is going to be 25 plus 1, which is just 26. Now we can write this in the form a plus bi. So this is going to equal to 13 over 26, right? And 13 over 26, that's just 1 over 2. So this is going to be half plus 13i over 26 is just the same thing as half I. So that's it. So we have the complex number w is equal to 3i minus 3, right? And z is equal to 4 minus 2i. Let's say that they want us to find w divided by z. Or w divided by z would be 3i minus 3 all over 4 minus 2i. Now we know that we must multiply the denominator, both the denominator and the numerator, by the conjugate of the denominator. So the conjugate of the denominator is going to be 4 plus 2i, right? So we're going to multiply the numerator with 4 plus 2i. Again, clearly the denominator is just a difference of 2 squares, so square the first term, so 4 times 4, that's going to give us 16 minus 2i times 2i, that's going to be minus 4i squared. Clear there? Again, let's use the distributive law to multiply the numerator. So we're going to use the first term to multiply the first term. So 3i times 4, that's going to be 12i. Then 3i times the second term. So 3i times plus 2i, that's going to give us plus 6i squared, right? Then we're going to use the second term to multiply the first term. So minus 3 times 4, that gives us minus 12. Minus 3 plus 2i, that's going to give us minus 6i. Clear there? Recall that I squared is the same thing as negative 1, so we can replace I squared with negative 1. So here we're going to have 12i plus 6 times negative 1 minus 12 minus 6i, right? All over 16 minus 4 times negative 1. Now that will give us a final answer of, here we have 12i and we have minus 6i, so we can combine those, right? So if we combine those together, 12i minus 6i, that's what's going to be 6i. Here we have 6 times negative 1, which is negative 6, minus 12, that's going to give us minus 18, all over. Here we have negative 4 times negative 1, which is going to give us positive 4, plus 16, that's going to give us 20. So the denominator is 20 here. Now we can always split this. So if we split this, this is going to be 6i over 20 minus 18 over 20. We can reduce these fractions, right? Both 6 and 20 can be divided by 2. So this is going to equal to 2 into 6, that's going to be 3. So this is going to be 3i over 2 into 20, that's going to give us 10. And minus 2 into 18, that's going to give us 9 over 10. Alright? Now this is the same thing, we can rearrange it around. So this is the same thing as minus 9 over 10 plus 3i over 10. Thank you for watching. Please remember to like, comment and subscribe.